Hi everyone, welcome to BIM Parametrics. I am Mohammed Shahrukh and welcome back to the fifth session of this series which we call the Netflix of BIM. So in the previous session we have seen about stage 6, the production stage, where each discipline develops its own detailed discipline specific model which is then coordinated and combined to form the federated model. Now that all the discipline models have been combined and our federated model is ready, one important question remains. How much detail and information does this model actually contain? Not every model in a BIM project carries the same level of information. Some may still in a conceptual stage, while others are developed enough for coordination, fabrication, or even for construction. To define and communicate this level of detail clearly, the BIM industry uses a standard concept called LOD or level of development. So let's take a look at what LOD means and why do we actually need it. So as a project develops, our BIM models continue to grow in both detail and information. But here is an important reality. Different stakeholders may need different information from the same model. Take a window for example. A contractor wants to know the manufacturer and model number of the window so they can order it on time. An MEP engineer or the designer only cares about the window's dimension and position to coordinate their ductwork, so they don't need the brand price or a brand or the price. In short, not everyone needs the same data. Some need graphical information, some need non-graphical, and others might need both of them. That's where the LOD or the level of development becomes essential. It defines not just how detailed a model element should be, but also how reliable and usable its information is for different project participants. For the purpose of this session, I would like to introduce you to one specific LOD system, the BIM Forum LOD specification. This specification is one of the most commonly adopted frameworks worldwide. It clearly defines how the maturity and reliability of model element increase as the project develops. In this specification, five distinct levels of development from LOD 100 to LOD 400 are used to describe how detailed and dependable each object in the BIM model is at different stages. The idea is very simple. At the start, elements are conceptual. As the design progresses, they become more accurate, coordinated, and detailed until finally they represent the actual build condition. So now let's take a closer look at these five levels and see how the model evolves through each stage. Now let's understand each level of development LOD one by one. And to make it simple, we will use the example of a window element. Let's start with the LOD 100, which represents the conceptual stage of a model. At this level, the element, for example, a window, is shown only as a symbol or a simple placeholder. It communicates that a window wall will exist here, but it doesn't define its exact size, material, or manufacturer. The information at LOD 100 is approximate only, used mainly for early design, space planning, and visualization. It helps the team understand the overall form and intent but not the detailed geometry or performance. Moving to LOD 200, the model becomes more developed. At this level, our window is no longer just a symbol. It's now a 3D object placed in the wall. It represents the approximate size, shape, and position of the window, allowing other disciplines to start coordinating their design. We may also include a few basic parameters, for example, the type of glazing, the sill height, or a general material. However, this information is still approximate. It's good enough for visualizing the design and for coordination, but not accurate enough for fabrication or ordering the components. Now moving to LOD 300, our model becomes much more detailed and precise. The window's size, location, and orientation are now exactly defined, accurate enough to be measured and coordinated with other disciplines. We also know what type of window it is, what assembly it belongs to, and its glazing thickness and dimensions are clearly modeled. At this stage, the information is reliable for detailed design, documentation, and quantity estimation. Next is LOD 350. The model moves into the coordination stage. Our window now includes all the information from LOD 300, but with more detail in its geometry and interfaces. Here, specific components like mullions, sills, and glass panels are modeled precisely, and the window is properly connected to the surrounding walls or the architectural elements. This level is used primarily for coordination and clash detection, ensuring that the window fits perfectly within the overall design and doesn't interfere with other systems such as structure or MEP. At this point, the model is accurate enough for review and design approval just before fabrication begins. The final level in the development scale is LOD 400, the fabrication and construction stage. Here, the element is modeled and with enough detail and precision to actually build or manufacture it. In our window example, this means we now have all the information needed to fabricate and mount the window on site, including frame profiles, hinges, handles, and even installation details. As we move up each LOD level, both the geometry and the information becomes more refined, making the BIM model a highly reliable and data-rich representation of the real building component. So this was the brief introduction of to level of development or LOD. We will explore this topic in much more detail in the future sessions of this series. But with that, we will wrap today's session here. In the next session, session 7, we will dive into BIM use cases and their benefits and see how BIM model serves multiple purposes, delivering value to every stakeholder involved in the project. Until then, I hope you have a great week ahead. If you found this session useful, don't forget to subscribe to the channel for the next episode of the next Flicks of BIM. See you in the next session and thank you for watching.